I have two alcohols that you can use for the second ester. This is Linalool here, and this is Geraniol here. Both come from plants. These alcohols have complicated structures, unlike ethanol or methanol. And what makes them challenging to work with is that this alcohol is unstable when exposed to a strong acid. Strong acid will provide H+ ions, which can protonate this OH here. When that occurs with this type of alcohol, you'll get the dehydration of the alcohol. And what makes this work in this case is that you'll get an ion that's actually fairly stable. Normally a carbon ion is extremely unstable, but this one is stabilized by the neighboring double bond and by the fact that this is what's called a tertiary carbon bonded to 3 other carbons. This is a carbocation. As far as carbocations go, this is rather stable, but it is not stable, and it will react in some way to become stable. This could react by losing a hydrogen, and you'll get a double bond somewhere. So the double bond could be here, could be here. You can also get rearrangements of carbon-carbon bonds when you have the carbocation, and things can shift around. So that means there are multiple products that could form here, and that's why this is a much more challenging alcohol to work with, because it will do some sort of reaction when it hits strong acid. Here I put some linalool, diluted it in an Eppendorf tube. I'm going to add some strong acid so you can see what happens. Here I've added 5 microliters of concentrated sulfuric acid to some linalool, and you can see it's turned dark. It's gotten very hot, indicating reactions have occurred here. So this is decomposition of the linalool catalyzed by the sulfuric acid. Here's a TLC of the original linalool on the left, one spot right there. This is the sulfuric acid with the linalool. You can see the linalool has decomposed into a number of different compounds, some which move very fast, some which move slower than the original. The reactions you've done previously reacted an alcohol with a carboxylic acid, needed a strong acid catalyst to make the reaction run at any decent rate. And what you should realize with the unstable alcohol, this is out of the question. You can't use sulfuric acid. There are a few strategies that you can use in this situation. You could try a different type of catalyst instead of the strong acid. So this is one catalyst that we have. It's based on the metal ytterbium, and this has been used in published papers as an alternative to the strong acid catalyst. So it may be that you can get this reaction to go with a different type of catalyst. The ytterbium ion can act as a Lewis acid, accepting lone pairs and polarizing the electrophile. An alternative strategy is to not use this carboxylic acid. This is a very poor leaving group here, OH, and it's possible to convert this into something better. We'll call it X. It's possible to take the original carboxylic acid, react it with something to turn it into a good leaving group, and then you won't need a catalyst. You can just have your alcohol attack this activated carboxylic acid and result in product. One example of this strategy that's commercially available, you can buy them, are what are called acid anhydrides. And they have this structure where you can see in place of the OH now we've got this as the leaving group, which is much more reactive than the OH. Probably the most commonly used acid anhydride is acetic anhydride. It's acetic acid. It's essentially 2 acetic acids stuck together in this way. And we have some of this in our solvent cabinet that is available for your use. Another molecule that can activate a carboxylic acid is this dicyclohexylcarbodiamide. This is actually a family of reagents that have this structure in the middle here, C with double bond N on each side. That's the carbodiamide. And This has been used for many, many years to react with carboxylic acids to turn them into a good reactive species with a good leaving group. Abbreviated DCC, dicyclohexylcarbamide, DCC. And we have some of this that is available for your use, again, in the solvent cabinet. Down here is where the Geraniol and Linalool and the dicyclohexylcarbamide are located. The ytterbium catalyst is here on the random organics shelf.